All right, let's quickly talk about watersheds. So watersheds are all of the area that flows into a particular body of water. So for example, around here we have Lake Ontario where most of our streams and rivers are flowing into. If I drop water anywhere around here, eventually it should flow into Lake Ontario, whether it goes in the Genesee River or Black Creek or even Irondequoit Bay. At some point it ends up in Lake Ontario. Some watersheds are very large. For example, Gulf of Mexico, that has the Mississippi River and Colorado River and all of the rivers flowing into it. And we can divide these up into various watersheds, just kind of mapping out where the water is flowing. So if we look at New York State, we got plenty of watersheds here in New York. Like I said, around here, mostly from the Finger Lakes north, it all flows into Lake Ontario and eventually the St. Lawrence River and then eventually the Atlantic Ocean. As we look further south in the state, the Susquehanna and the Delaware rivers, they actually flow down into the Chesapeake Bay, but they also end up eventually in the Atlantic Ocean. Now, where that water flows defines what the watershed is, where it eventually ends up. A tributary is a smaller river that flows into a larger river. It's kind of, making the river bigger. So as you move through a watershed, typically it starts to consolidate down into one larger river. So the Mississippi River has lots and lots of tributaries. And by the time you get down here to the end at Louisiana, New Orleans, you've got a very large river flowing into the Gulf. So the evolution of a stream, youthful streams, they're swift flowing streams. They begin in higher elevations. They're usually narrow and fairly straight. They have waterfalls and rapids, and these are common things that we find in a youthful stream. Over time, the river moves from side to side, carving out a floodplain where sediments are deposited during a flood. So we have mature streams. They begin to erode outwards. They become wider and wider as the current decreases. So they're usually wider and slower. And they curve in the river, they form curves in the river called meanders. So we've got a stream evolving right here. We've got these two meanders occurring, and on the outside of our bank, it's going to start eroding and moving and making these meanders bigger. So the outside we call the cut bank. The cut bank is when the bank of the stream erodes at the meander. The sandbar is going to be when deposition occurs on the inside of the meander. So if this is the meander right here, this is the curve. The outside is the cut bank, that's eroding because the water is moving fast. On the inside, we have a sandbar. The sediments are being deposited because the water is moving slowly. So here we got an aerial photograph of a meander. So this river right here, this outside part over here and this outside part over here are the cut banks. So they are moving in opposite directions. Eventually, what we're going to see happen is an oxbow lake is going to form. But we need to know that on the outside of our meander, erosion is going to occur, and on the inside of the meander, deposition is going to occur. Cut bank and sandbar. So as I said earlier, over time, the river is going to move side to side, carving out a floodplain. This is where sediments are deposited during a flood. So that's going to be a flat area surrounding the river. Usually you can see them, there's going to be a river, and there's going to be an area surrounding that's mostly flat. That's because this is the area where the river has continually deposited and eroded sediment. So you can see right here, this is how a stream matures, right? At the beginning, it may have steep sides, fast moving water, and in a small channel. And as it continually erodes at those sides, the floodplain begins to grow, and eventually you have an old age stream that has oxbow lakes, lots of tributaries, and a large floodplain. So here we got an example of a floodplain. This is in Yellowstone, and we can see right here, this river right here flowing has carved out that whole flat area. Now, it's not always full of water in this flat area, but during a flood, it will. So Last thing about evolution of a stream. Old age, they're wide, slow-moving river with more deposition than erosion. Lots of meanders. They have oxbow lakes. These are cut-off meanders that form a lake. So you can see this right here. If we've got two cut banks that are facing each other, as they start to erode towards each other, eventually they're going to connect. And the water is going to take the path of least resistance. It's going to flow and separate that lake from the original river. So you can see here some examples. We see old oxbow lakes. These used to be meanders in the river, and now they are entirely separate. All right, so here's a stream. We're going to look at where erosion is occurring, where deposition is occurring. So erosion is occurring on the outside of the meander, and deposition is occurring on the inside. And then we're going to look at the profile view. So when the river is straight, the deepest part is in the middle, and on the sides it gets shallower. But when we are in a meander, the deepest part is going to be where erosion is taking place on the outside of the bend, and deposition is going to occur on the inside of the bend, so it's going to be shallower. All right, let's talk about horizontal sorting for a second. So due to changes in gradient, discharge, velocity, or a combination of all of these, what's going to happen is you're going to have larger particles deposit close to the mouth of a river and smaller particles deposit further from that river. We call this horizontal sorting because on one side we have large and on the other side we have small. So as you move from one side to the other, the particles are sorted, they're organized, they go from large to small. This forms a delta. So this occurs when a stream enters a quiet body of water, and you have these finger-like deposits of new sediment that have been transported from upstream that are being deposited in that body of water. This one right here, this is the Mississippi River Delta. So oftentimes delta will form like a fan type appearance, but not always. You know, they can be this kind of finger-like appearance that we see in the Mississippi River as well. Settling rate. All right, sediments that are larger settle faster than smaller sediments. Sediments that are flatter settle slower than sediments that are rounded, right? The larger my particles are, the faster they're going to settle out. And the less round they are, the slower they're going to settle out. So if they're flat, they're going to kind of, sink down. Think about a leaf falling off of a tree. They're not going to go in a straight line down to the bottom. The same thing happens in water. When you have large, flat particles, they're going to kind of take their time to get down to the bottom. So rounded ones are going to settle faster. Sediments that are denser are going to settle faster than sediments that are less dense. Factors that affect stream velocity. So discharge, that's the amount of water that the stream is going to carry. It's going to affect how fast the stream is flowing. As stream velocity increases, as discharge increases, stream velocity is going to increase as well. Gradient, the slope of the land, how steep or flat it is. The steeper the slope, the faster the stream velocity. So if I've got a high gradient, steep slope, my stream velocity is going to be much faster. Stream channel shape. So the wider or flatter streams have slow-moving water. Narrow streams typically have fast-moving water. So the wider my channel shape is, the slower my stream is going to go. Think about pulling your hand over a hose. The smaller you make that opening, the faster the water comes out of it.